Following examples are about infinite limits. These can be found in section 1.4 of your book. Example 1. The limit as x approaches 1 of 2 over x minus 1. Whenever we are finding a limit, our first step should be plugging in to see what happens. So when we plug in here, we get a 2 on the top and 1 minus 1 or 0 on the bottom. Whenever we have a constant over 0, this is an indication that there might be a vertical asymptote happening at that spot. So when we think that is happening, what we can do is we want to investigate the left-hand side and the right-hand side separately. All right, let's look at the left-hand side first. This means we're looking at the limit as x approaches 1 from the left of 2 over x minus 1. The top will go to 2. It's a constant. And now we want to think about plugging in something just slightly smaller than 1. We're going to think of this more with a numerical approach. If we plug in something slightly smaller than 1, 0.9, 0.99, 0.99999, that subtracting 1 will get us a very small negative number. We're talking very, very tiny, like negative 0.000000001. Let's think about what that means. We know something infinite is happening because we have that vertical asymptote situation. So when we're looking at this, we see 2 over a very small negative number. That is our indication that this is going towards negative infinity. We know it's infinite because it's a constant over a very tiny number. Because that number is negative, positive divided by negative is negative infinity. All right, let's look at the right-hand side. The limit as x approaches 1 from the right-hand side of 2 over x minus 1. Again, the top goes to 2. And now let's look at the bottom. We see we want to plug in things like 1.1, 1.01, 1.001. As we do that, if we subtract 1 from it, we're going to have a very, very tiny, a very, very small positive number now. So 2 divided by a very, very tiny, tiny, tiny positive number is going to go towards positive infinity. So what is happening, let's kind of make a very basic sketch of what might be happening in this graph. So we're looking around 1, x value of 1. It looks like on the left-hand side, we're approaching negative infinity. So we don't really know what's happening in the rest of the graph, but we know that it's going down forever. And on the right-hand side, we're not sure exactly what's happening but we know as we get close to 1, we're going up towards infinity forever. So on one side, we're going down forever. The other side, we're going up forever. These don't match. So these two things together imply the limit does not exist. If they had been both going towards infinity or both going towards negative infinity, we would have indicated that. But they're going opposite directions, so this one does not exist. All right, here's our next example. The limit as x approaches 3 of 4 over x minus 3 quantity squared. Again, we always start by plugging in just to kind of see what's happening, to give us a clue of which way we should go if something weird is happening. When we plug in, we get 4 over 0. Again, that's a clue that there might be a vertical asymptote happening at 3. There actually will be one happening here at 3. So we're going to check both sides individually to see what's happening. Are they both going toward infinity, both going toward negative infinity, or are they going opposite directions? So let's look at the left-hand side. That's the limit as x approaches 3 from the left of 4 over x minus 3 squared. All right, so when we plug in something slightly smaller than 3, we're talking 2.9, 2.99, 2.99999. We're going to have 4 over. Now look inside the parentheses, that 2.9, 2.99, 2.9999. When we subtract 3, it's going to be a very small negative number. So we'll indicate a small negative, but I'm going to square it. So let's think about what that means. This is 4 over. That negative squared will be a very small positive. So what that's telling me is that this side is going towards infinity. The left-hand limit is heading towards positive infinity. Let's look at my right-hand side. The limit as x approaches 3 from the right of 4 over x minus 3 squared. Again, 4 on top. Now I'm plugging in like 3.1, 3.01, 3.001. When I subtract 3 from it, I will get a very small positive number. But then that square, I'm still going to square it. And 4 over a small positive number squared is still a very small positive number. So the right-hand side is also going to infinity. So again, this is a basic sketch. This is not exactly what the graph looks like. But right here at 3, on the left-hand side, it's going up forever. And on the right-hand side, it's going up forever. So it looks to me they match. Since they match, this all together implies that the limit is infinity. The left and right hand match, therefore the limit is infinity in this case. All right, let's look at another one. We've got some trig going in here. So again, plug in, see what happens. That's always where you should start. So we'll get -2 over, and then the cosine of pi over 2 is 0. So we are getting that constant over 0 situation, which indicates some sort of infinite limit might be happening. So I'm going to look at my left-hand side first. So this is the limit as x approaches pi over 2 from the left-hand side, -2 over cosine x. So the top will be -2, just that constant. And now I want to think, if I want to approach pi over 2 from the left-hand side, I'm in that first quadrant of my unit circle heading up towards pi over 2. So as I get really close to pi over 2, my cosines are positive, so I will have a small positive number here. -2 over a small positive number, a negative constant over a very small positive number, that means that's our indication that it's heading towards negative infinity here. On our right-hand side, we want the limit as x approaches pi over 2 from the right of -2 over cosine x. So again, the top is -2, and now I want to approach pi over 2 from the right-hand side, which means from numbers bigger than that. So you can imagine I am in the second quadrant heading towards pi over 2. Well, in the second quadrant, I have negative cosine values. So this is going to be a very small negative number as I head towards pi over 2. Negative over negative, well, this will be a positive infinity. And then what I notice, these don't match. So these do not match, which implies the limit does not exist. So kind of the idea, again, we'll just say maybe this is pi over 2 on our graph. On its left-hand side, it's not really sure what's happening otherwise, but as you get close to pi over 2, we're going towards negative infinity. And as we get close to pi over 2 on the right-hand side, we're going to positive infinity. So it's not matching. Again, I don't know what the rest of the graph is doing, but I know right there near pi over 2, the left side is going towards negative infinity and the right side is going towards positive infinity. Okay, our next example. Let's look at this one. Again, plug in, see what's happening. If I plug in, I get a -1 on top and a 0 on the bottom. Again, that indication to do this left-hand, right-hand side kind of situation. So my left-hand side, I will look at, so this is the limit as x approaches 2 from the left of x minus 3 over x squared minus 4. Okay, well, the top is heading toward -1. I can just kind of plug that 2 in. It's really the bottom that is the issue. So if I think about what's going on here, 2 from the left, I'm thinking 1.9, 1.99, 1.999999. And then I'm going to square it and subtract 4. Well, if you square something that is slightly smaller than 2, you're going to get something slightly smaller than 4. So when I take this number that's slightly smaller than 4 and subtract 4, I'm going to have a very small negative number on that side. And so negative divided by negative, I know something infinite is happening. This is going to go towards infinity. My right-hand side, the limit as x approaches 2 from the right of x minus 3 over x squared minus 4. Again, the top is negative, heading towards -1. I'm okay with that. It's the bottom that's the issue. Plug in something slightly bigger than 2, so 2.1, 2.01, 2.01, that kind of idea. When I square that number, because it's larger than 2, it's going to be larger than, its square will be larger than 4. So something slightly larger than 4, when I subtract 4, I'm going to have a very tiny positive number. So I have a small positive number on this case. A negative divided by a positive is negative infinity in this case. We know something infinite is happening. These don't match. Remember, your left and right hand side have to match. So that implies this limit does not exist. And again, not a perfect graph, but if we kind of thought about what's going on here, over here at 2, the left-hand side is going up towards infinity, and the right-hand side is heading towards negative infinity. All right, another example. The limit as x approaches 0 of 1 plus 1 over x squared. If I plug in, I get, well, if I plug in a 0, I get 1 plus 1 over 0. So this 1 over 0 is indicating something infinite is happening in this piece. So what I'm going to do, when I have the limit of two things added together, I can take their limits individually and then add together their respective limits. So I'm going to look at this as the limit as x approaches 0 of 1 plus the limit as x approaches 0 of 1 over x squared, because I already know that answer is 1. So now I'm just going to focus on this, the part with the infinite thing happening. And then not forget that at the end, I might have to add 1 to it depending on what's going on, okay? All right, so what do I get here? I've got that infinite thing going on, so I'm going to look at the left-hand side and the right-hand side. If I look at the left, I have the limit as x approaches 0 from the left of 1 over x squared, okay? So that'll be a 1 on top, and then 0 from the left, so that's like negative 0.1, negative 0.01, negative 0.01. And then what am I going to do? I'm going to square it. So when I square that tiny negative number, I'm going to end up with a very small positive number, which indicates this left-hand side is heading towards positive infinity. All right. My right-hand side, the limit as x approaches 0 from the right of 1 over x squared. I'm still 1 on top. And now I'm going to square, or I'm going to plug in some very tiny positive number, 0.1, 0.01, 0.001. When I square that, it will remain a very tiny positive number. And that indicates that the right-hand side is going towards infinity. Okay, so what is going on with this limit as x approaches 0 of 1 over x squared? I'm noticing that these match. They're both heading towards infinity. So that implies that limit is heading towards infinity. Now, what did I just find? I found this one, right? The limit just as we approach 0 of x squared, 1 over x squared. I ignored this part. So I need to go back and pay attention to it. So that whole limit as x approaches 0 of 1 plus 1 over x squared is, well, 1 plus infinity. But according to our properties of infinite limits, if we have the sum here and one is infinite and one is a constant, that infinity dominates the one. So this is just infinity. All right, and let's look at one more. We've got some trig in here now. So again, always plug in to kind of see what's happening. Start there. If we plug in a 0, I get a 3 on top. And then the cotangent of 0, we'll think about what's going on there. Might help to think cotangent x is cosine x over sine x. So the cosine of 0 is a 1, and the sine of 0 is 0. So it's kind of weird. 3 divided by 1 over 0. Weird things are happening here. So I'm going to have to do something to make sure I'm analyzing this correctly. And one thing that's very handy with trig, especially since lots of them kind of come from fractions, I'm just going to rewrite this as x squared plus 3. A cotangent in the bottom is really a tangent in the top. Maybe this will help me think of it a little bit better. Okay, so now I'm going to plug in a 0. If I plug in here, 0 squared plus 3 is 3. And then the tangent of 0, well, that is 0. So this is like 3 times 0, or 0. And we're done. So this one looks sort of like something weird is happening. We have this undefined in the bottom when we have this cotangent. But with trig, we can generally rewrite a lot of times, especially because we know there's lots of fractions. We can break down things. That rewriting will often help us analyze our situation a lot better.